common goal is to develop a complex system. Developing complex systems requires the integration of multiple engineering domains. But this, on the other hand, has proven to be a great challenge. Usually, engineering domains tend to function in their own encapsulated silos. This is generally a bad precondition when developing complex systems due to the interference of these silos. As a result, integrations tend to fail and need to be adjusted or sometimes even redesigned, which in line results in delayed releases, an increase of costs, and unsatisfied stakeholders. By leveraging the power of OSLC, the walls of these silos become transparent. Changes in one silo, which have a dependency to other silos, become visible based on real-time information. This enables engineering teams to detect and solve integration challenges in the early phases of the project. We will now demonstrate what this can look like in a real-life environment. In this example, you will see how OSLC can be used to trace and provide information across engineering disciplines and tools. We start in the requirement engineering discipline by introducing a new requirement. This requirement is on a system specification level and derived from a user requirement. Therefore, we will link it to the corresponding user requirement. The next step is to refine the system requirement by one or more use cases. To do this, we will now switch to a modeling tool. OSLC allows access to the requirements also in the context of our modeling tool. In order to see our newly introduced requirement, we perform a refresh. Now we have the new requirement accessible, and it can be used in our use case diagram, and refine it with the use case. The next step is to associate our use case with, in this case, for example, the actor. After which we create a dependency between our new use case and our new requirement, which in turn initiates a refined OSLC link. The use case should be specified even more precisely. As an example, we add some description and finalize this step by saving the model. When we go back to our requirements management tool and perform a refresh, the new use case becomes visible. Without the need to switch back to our modeling tool, we can do a deep dive into the use case details by performing a mouse over on the OSLC link at any given time. We just saw how the level of the digital twin based on OSLC can be related across different engineering domains and tools. But OSLC goes one step further. Processes, also called digital thread, can be managed across engineering domains and tools. For this purpose, we now focus on the implementation of a change in the context of change sets. We're not so much interested in the content of the change, but in its workflow across roles and disciplines. The task is to adapt a requirement, for which there is a ticket in Jira. The requirement engineer works indoors and would like to complete this task now. For this purpose, he has a change set in which all necessary changes are collected. First, the change set is linked to the Jira ticket. Now the actual change is executed. This is done in the local sandbox. When all changes are done, they are committed to the current stream based on the change set. Once the changes have been made, it is time to deliver the change set. As you can see, we get an error message. This is also correct, because in this case Jira has a gate built in. For example, because the changes have to be reviewed before committing them using the 4 I's principle. In order to solve this, we need to put the Jira ticket in the done state, or also called approved state. Once this is done, through OSLC, this real-time information is being sent to Doors Next. It is now possible to deliver the change set and merge our changes into the global configuration. Being able to identify and solve integration challenges at an early stage in the project is the best guarantee of project success in terms of stakeholder satisfaction, cost, and product quality.